Hello, everyone. It's me, um, Brian. How you doing? It's Friday. Got some good news. I was able to actually get everything straightened out of my office, so my power will be back up and running. I do not know how or why the power ended up the way it was, but we had an electrician come out. Spent I don't know less than an hour trying to figure out what was up. So great to have my office back to 100%. I just have to shut everything down and move everything back to where it was. So that has been I'm not even completely done yet. So I'm glad you're able to join me. My problems are not your problems. Doesn't mean I can't vent about them though. So yeah, we're heading into the weekend. I want to get back into the Rust and things that we were doing. So let me. Problem is when I switch over to the VS Code stuff, it's going to get really, really big. I need to go to studio mode. VS Code Fridays. Yeah, that's what I was afraid of. Okay, so shrink up the VS Code UI here because I think I have it set full screen. I do. Let's shrink that up a little bit. I can move that over. The other reason it took me a little while was because I was trying to find where everything was. Hey, Beta Wolf. Love that I convinced you to get into Rust. Hello to the stream. Hello, podcast. Hello, YouTube. I'm going to let you believe that. No, I'm just kidding. Let me move my uncomfortable weight bench over. So, yes, thank you, Beta Wolf, for the kind discussion and suggestion that I embrace yet another programming language. Are you doing okay? Have you heard anything more about your work-related issues there, Beta Wolf? I hope that it will come to a head fairly soon. And I did see that on several sites that they'd confirmed what you had said as well. So um, it's unfortunate that is what is going to happen. So all right, there's my screen. I'm going to turn that off so everybody can see what's going on. I have several things going on here. Let me move the browser window. All right, so I can see I don't want to do that. Oh, well, actually, that's not so bad. Maybe I'll do that. Okay. So I managed to put half and half on the screen. I got to run, unfortunately. Oh, okay. Yeah, but we'll take care of yourself. Have a good weekend, and it'll be just me until some lurkers come out of the woodwork. So have a good weekend, sir, and take care of yourself. So, all righty, let's go ahead and get back into this. So, for those of you first time maybe watching the stream, going, "Hey, what's he doing with Rust?" There's a link to a blog post from this person, which I will put in our chat. Doink. There you go. And if you follow that link, it will take you to a website where this person named Philip Opperman didn't actually know his whole name. So there you go. Philip Opperman wrote a blog with a series of entries about how to write your own operating system in Rust. And so there'd been a few news stories out there that Microsoft was changing a lot of its kernel over to Rust because it's a memory safe operation, memory safe program. There's, it's better than, and I wouldn't say better, but in some people's opinions, that was the better way to go. So Microsoft is in the process of upgrading its OS to include things like Rust, which kind of makes me wonder, the future of Windows is going to be probably open source. They're going to open source Windows at some point because they have I would say they're still getting licensing on things. It's probably still a cash cow in some respects, but I could see a Windows Community Edition coming out. They're embracing a lot of Linux stuff. You can run obviously WSL on Linux on Windows. It's almost a full OS running on top of a hypervisor, which is once they open source the kernel, you can do a lot with what's going on in Windows. And then Microsoft could do a freemium model where it's like, hey, we'll give you the OS for free, we'll give you a bunch of bells and whistles on the back end, or tighter integrations with Azure, that kind of stuff. So I would imagine the change to something like Rust would be to make it more friendly to open source, to get rid of items that are proprietary, kind of like a declassification of what's going on there with Windows for the last 20, 30 years. So I could be wrong. It could be another, I've been calling this for a while. So I'm hoping that that's what'll happen. I don't have any inside secret sauce or anything like that. So don't take that all as a conjecture and prediction that, Linux is the desktop, Windows is OS, is open source kind of thing. So, but what I've been doing, what I've been trying to do during my streams on Fridays when I can, is go through how to build an OS. And so we've gone through the freestanding Rust binary. We've created our own operating system kernel. I did run it in QEMU, which I've shown on previous streams. We did create a minimal Rust kernel. We did set it up so that it would boot to it would load up a, hey, here's welcome to our operating system kind of thing. And we're now going into the testing phase of. I thought for sure I'd shut off my work computer. You know what? I don't want to do that. Let me double check and see what's going on. Hope everyone's having a good weekend. Good weekend coming up. We're going to be very busy. We're going to go watch Mamma Mia in San Diego at 2:00. So if you're at the same Mamma Mia in San Diego, if you see me, wave, come over and say hi. It doesn't happen often that I get recognized. So I'm not saying, you need to come out and go out of your way to do so. If you just want to wave, fine too. Or, just so, avoid me like most people do anyway. So anyway, just checking. Okay, so should not have even turned this on. Now I need to lock my workstation for the weekend. So, come on. There we go. Getting my other monitor up here so it won't accidentally activate that one. And yeah, so we're doing we're going to be doing some unit tests apparently, or something very exciting with regards to the development process. I'm guessing we're going to test and make sure we don't have any hot mess going on with our system. So there's my little lion head. I'm going to put it down there with me. So, all right. Also, I've heard if you make sure you watermark all your videos in case somebody tries to put your shit up on Udemy. I'm assuming that nobody will do that because nobody wants to listen to me talk, and because of my language, it would probably get kicked off of Udemy anyway. So I've understood that some of the training that you get on Udemy has content requirements. One of them is supposed to be somewhat professional, no bad language. So the 7 things you can't say on TV, which are now like 5 or 4, will get me banned from Udemy. So if anybody tried to take my stuff and put it on Udemy, they probably would get banned too. So there's a plan. I have a thinking. Yeah, that's what I've got, such as it is. All right. So as you see here, the last little bit of I think that yeah, see they're talking bare bones here. So the bare bones, this is not like beginner, intermediate, advanced. This is bare bones, and then interrupts, and then we're going to talk about, eventually we're going to get all the way to the bottom of this where we'll actually have multitasking. So we're gonna go through this. There is a GitHub for this, and I will post up that link in chat as well. And we're gonna go through testing. So this is chapter 4 for all intents and purposes, and the branch for that is right here. Now, be advised if you're following along in your book here. Power to the F bomb. Thank you, Age of Music. Yes, 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 yes. Um, yeah, power to power to the fuck. So, just be advised if you're actually following along on the exercise and you go to the GitHub page and you can't find that code in, from the chapter that we're doing here. Phil liked to do something and then go, oh, look, it doesn't work now. And then by the end of the document, he's ripped out the stuff at the top of the document and none of that stuff exists anymore. Again, don't ask me why. I almost feel like I need to go in reverse. Maybe like look at the finished product and go, how did we get to that point? And maybe that's something we will do if enough people ask for it. Oh, okay. Thank you, Age. Appreciate it. All right. So, and before we continue on, let me make sure that we don't have any new followers or new people thinking. Nope, nobody new has joined us here in our happy land. So, I will continue on. All right. So, this post explores unit and integration testing in no standard executables. No STD, of course, being no standard input or output. We created a special kernel for this that we source main RS. All right, so what you're seeing here is the code that we have currently in our main RS. There's, okay, I don't like the, oh no, that's not good. Okay, I don't, yeah, okay. Didn't want to do any of that right there, but I guess I did that anyway. Mr. This is my father. You can call me by my first name, Mr. No, that's an old joke. All right. So the blog is openly developed in GitHub. If you have any problems or questions, open an issue. You can also leave comments at the bottom. Complete source code for this post is found in the post-04 branch. Here's the table of contents. So we've got testing in Rust, we're going to custom test frameworks. So we're actually going to create test frameworks, which is actually quite valuable, not just from an OS point of view, but if you do any kind of development, you're going to want to create some test cases or create some unit tests that, if not you, then the QA team is going to have to create those to test various inputs or various things in your environment. So testing frameworks also have to, do a lot with things like fuzzing. So you're testing by taking input or giving input to the system and seeing how it will react to that. So this is going to be interesting. Is we're going to learn a little bit outside of what I planned on doing with the OS. So we're going to learn a bit of testing. Test harnesses are. I had a lot of very talented people when I worked at Leviathan. When they would work on an engagement, they would spend a couple days writing test harnesses. And as a PM, when I was going through the engagement process with them, they'd ask me, hey, can we talk to the application team to see if their QA team has use cases or test harnesses that they already have in place, so that they didn't have to rebuild a bespoke system every time they did it. They could do that, but when you have when it's the time boxed engagement and you're spending 10 to 15% of the test engagement writing a test harness for something, when you could get like some Postman or some kind of unit test cases that they could just automate the process, makes it a little easier. So I always make sure I try to ask that as a good PM and I use the argument that it was a better use of their time to find issues and vulnerabilities instead of having to build the test stuff to test their information or their stuff. So it made a lot more sense to do so. Okay, let me see. All right, so there's a little caveat to this chapter. It says this post replaces the now deprecated unit testing, and integration test posts. So there was apparently, yeah, see, this is, excuse me. So it says, it's deprecated. There was some suggestion. Wow, there's quite a bit of work in here talking about various ports. So there might still be some good nuggets of information in here about integration testing. Uh, you might want to check those out just to, see how you might, do this differently. I'm not sure why he deprecated it. Maybe he thought that the other way is more succinct. What it may feel like is, well, I've taken 2 times the material and I've combined it into one. Now, either it's a super chapter, which means it's twice as long as the original two, or he realized maybe he had gone too deep into something and realized that just the regular testing post is going to be good enough. So I would suggest looking at all three. Maybe you want to look at the deprecated stuff first and then go to the regular testing to see, okay, he glossed over this in the new section, or he went super deep in this and he didn't go deep enough in the original post. So just a thought there on taking a look at some of these items. So we're going to go back to the regular testing post. So he says it also assumes that you have followed a minimal Rust kernel post after this date. Obviously, this is November 10th, 2023. So we're 4 years after this post, roughly, almost 5. And it says mainly it requires that you have a cargo config.toml, which we actually do. We have a config.toml, right? We don't have a config.toml. What? Where's our .cargo file? Oh, where's our .cargo file? Do we not have one? Well, interesting. Yeah, I thought we did. Oh, you know what? I'm wondering. Oh man, I hope. Oh, here we go. Okay, so I need to. Okay, so we're in Rust OS. Rust OS. We do have a .cargo. We do have a config.toml. So if you remember in our previous streams, this sets specific compiler flags and architecture stuff so that you don't have a big long QEMU, or when you're running your build functions, you don't have a bunch of targets and things, and it makes it super long. So you can run like cargo build or whatever, and it will take these variables up here, these variables in this case, and build according to what's in here. So yes, so I was looking in the wrong side. This is my personal page, not the Rust OS page. The Hello Rust comes from something else that we did earlier, dealing with some previous projects. So we have our Rust source. Let me go ahead and close out some of this other stuff that doesn't make any sense. Source, here's our main RS, which this is what our initial kernel looks like. These are the areas, as you can see, where we've had, we've added last time we added our VGA buffer. We have something that will manage error messages if we get them. This is where we created a somewhat safer method by which we're injecting ourselves into memory. And here's our VGA buffer. So the VGA buffer is the module that we use. This is where we inject ourselves into memory at the location, memory location B8000, and we'll boot up, and they'll give us an error message or give us a a welcome message or something like that. And so the hello world is what will pop when we load it up and build it in on the command line and run it through QEMU. So, all right. So, per discussion here, so testing in Rust. Rust has a built-in testing framework. Click on that and you see, so in the Rust docs, which is the Rust Bible, if you will, official documentation, you see where they talk about automating tests. So 1972's essay, The Humble Programmer, Edger, I'm not going to pronounce this name because I've done runt it. So that person said that program testing can be a very effective way to show the presence of bugs, but it is hopelessly inadequate for showing their absence. That doesn't mean we shouldn't try to test as much as we can. Okay, correctness in our programs is the extent to which our code does what we intend it to do. Rust is designed with a high degree of concern about correctness of programs, but correctness is complex and not easy to prove. Rust's type system shoulders a huge part of this burden, but the type system cannot catch everything. As such, Rust includes support for writing automated software tests. So there you go. You can read that out. Let's go find this essay, The Humble Programmer. There you go. So you can read the Humble Programmer Manifesto. I'm assuming it's some kind of programming manifesto for programmers, much like the Salzer and Schroeder paper is for computer security, or Aleph One's Smashing the Stack for Fun and Profit, which I saw, I think it just celebrated its 35th anniversary in the annals of hacking history. So how big is this manifesto? Oh my goodness. Okay, so it's a little long. Some of the programming methods and terms in there may be a bit dated. Algol, I saw Algol. Lady P probably understands Algol. Fortran, Fortran's still used around. Lisp is still somewhat. Here's the Algol, yeah, Algol 60, algorithmic language. So there is a number of things. Oh, PL1, a programming language defining documentation of framing size and complexity. So, you're probably going to have to go look up what some of these things are. I know I would have to. So, just to understand maybe what this person had to deal with in 1972. To be honest, I wasn't born in 72. No matter what my wife and I have with this little bit where I was actually, at the Olympics in 1972. Anyway, you can go read that doc if you want, and we'll get back to our discussion here. So, Rust has a built-in test framework capable of running unit tests without the need to set anything up. Okay. Just create a function that checks some results through assertions and add the test attribute to the function header. Then cargo test will automatically find and execute all functions, test functions of your crate. Sounds too good to be true. I mean, yeah, okay, so, unfortunately, it's a bit more complicated for no standard applications such as our kernel. Problem is, Rust's test framework implicitly uses built-in test library, which depends on the standard library. And since we don't have the standard library, because I'm, I've slept since then, so I forget why we don't have that. We'll have to go through and create a cargo test specifically for our project. So, yeah, because he says, close this terminal. I'm going to open terminal again. Here we go. Code projects, and it's going to be cd rust os. There we go. And then ls. So there's our cargo toml cargo lock. This is our directory with all of our stuff, including our JSON file for that. .cargo source target. All right, so if we do cargo test, yeah, we see we get a ton of error messages dealing with that. I'm assuming that that's what we'll see. Can't find crate for test. Oh, so that's even worse. All right, so let me scroll back up. There's only 1,000 errors here, so that's good. Yeah, can't find crate for core as well. Can't find crate for compile. Okay. Okay. All right, so cargo, when I do cargo build, what happens? Oh, I'm getting a ton of error messages anyway. So this is the problem with, not keeping up with all of, not doing this on a regular basis. You end up, taking a couple weeks off and then you're causing issues. So, okay. Well, we may have to make some tweaks. So, all right. It ain't like falling off a bike. Yeah, it's not easy to get back on that bike in this case. So, yeah, that's 100%. Um, okay, so since the test crate depends on standard library, it's not available for our bare metal target. While porting the test crate to a no standard is possible. Excuse me. Okay, so this repository has been archived by the owner on April 11th, 2021. It's now read only. I don't recommend this approach for testing no standard code as it relies on unstable details about the Rust compiler and the standard library, so it's prone to breakage. For a stable approach, you can use a custom cargo runner and a procedural macro as it's done in the defmt test crate. If you'd like to know more about testing embedded Rust firmware in general, I recommend this series of blog posts, which are okay. Okay, testing an embedded application, running hardware in the loop, testing a driver crate, testing a hardware abstraction layer, hardware abstraction. HAL. Okay, so HAL is, you find that in even Windows has a HAL, hardware abstraction layer. So I'll grab that. Boink. There we go. We will go back. All right, so I won't bore you with that or that or that or that. All right. So back up. I think this is okay. This is old. All right. So fortunately, Rust supports replacing the default test framework through the unstable custom test frameworks feature. This feature requires no external libraries and thus also works in no standard environments. It works by collecting all functions annotated with test case attributes. So this is an attribute that we'll have to put in our code somewhere. Of course, I'm going to have to figure out why this isn't working and I have to build it again. So maybe cargo, let's run cargo run real quick here. Cargo run. Maybe I'm not in the right directory. If you'll indulge me for a second, let me go back to chapter 1 and I will make sure that we've got everything set up to go. Okay. We've already done all that. Yes, we're beyond that. Okay, so unwinding, yes, start attribute, linker errors. All right, bare metal target. Okay, so we need to Rust C version of verbose. Okay, so we've got that. That's our Rust C, our binary, and that's our information there. Okay, LLVM is 17 versus the version 8 for LLVM. We have our build target inside. Yep. So Rust up target. Okay, so we have already added this inside of our config.toml. So there's our build target using the JSON file. There's the JSON file. And then so we build. So I will just copy this. Actually, let me add target copy. There we go. Okay, so that worked. Downloading and installing Rust standard. Okay, and then cargo build. Copy. Could not build due to previous error. This crate supports only the x86. Mm-hmm. Right. All right, so yeah, we have our cargo config.toml file. We added all the necessary bits. Cargo build this binary. We need to build a bare metal target. We've already done this part because I already tried that and it didn't work. Right, that's the definition of insanity. I did that. All right, okay, so we UEFI target specification. All right, we've got all that. The JSON file that describes x86 unknown GNU is right here. You can see the code for that. Okay, got that. Now, obviously, we're not in this is not chapter 4, so they added a bunch of stuff in for the system here for that. And linker LLD, yeah, we've added that. Rust, panic is abort, red zone. We added these features. There's the specification code, so it all matches. Little 6432 OS none equals true LD LLD Rust abort true. Yep. Okay. So building the kernel. Okay. So we need cargo build. Copy. All right. So that's interesting. It's right there. Okay, target. Right. Target path is not a valid file. Oh, duh. Okay. Again, this is why you don't assume anything. 1 second. So when you don't follow the blog post exactly, you're going to run into issues like path was not found or blog OS was not found. That's because I ignorantly changed the files. So, and then I'm getting error messages. So great. Can't find crate for right. Okay. So default target. Right. Print screen implementation. Running our kernel. Go install boot image. Make sure we've got all of our stuff. It's going to build all this stuff, and it should run QEMU and should allow us to see the overlay when it's done. Let me see if I've got QEMU in here. Yep. Okay. Ooh, boy, that made things go vroom a little bit. So, all right, so it compiled all that, and then it says now we can boot our QEMU system. Now I will need to change that blog OS to something else. Let me see. It should be Rust. Well, I just pooched something up real good, didn't I? Oh, oh yeah. I screwed that up. Okay. Yeah. Yeah. I can't even find QEMU system x86, right? Hmm. Let me double check and make sure QEMU actually. Let me make sure QEMU actually exists. Well, that would also be the problem, right? I don't know why it can't find QEMU. QEMU system x86 64. Oh, okay, that might also be the other problem. I don't know why I'm not getting. I don't know why I'm using PowerShell either. So, all right. So let me use the proper WSL output. I don't know why I was trying to use it in the. All right, so QEMU. There we go. Okay, so remember, kids, don't ever deviate from the system. Don't ever deviate from the system, kids. Don't be like Uncle Brian. Okay, good. Okay. So that's good. Everything's running. Created a boot image. Right. Okay, now let me QEMU system X. Okay. And then drive file target. Copy. I want to go and let me pull up my terminal window here to make sure that I've got everything right in the in directory code projects target Rust OS. Nobody can see this on the screen. That's something I'm trying to look at first. So target cd target, right? Target works, and then x86 64 Rust _ OS. All right, so I wanted to make sure that that was correct here. Rust. And then okay, double check that. CDX. And then CD debug. And then boot image. Rust capital. Ah, yes. Okay, so yeah, I've pooched it a couple times here. So, all right. Again, that's why you follow the tutorials to the letter. You don't make your own directory structures. You don't, get cutesy with the new names and everything. You just follow the damn tutorial. That way you don't end up wasting your stream doing this kind of thing. So, and then, okay, so that's good. At least it can't find. Oh, that's because you only wish you were here. No, I've seen it so clear. To add to the complication. There we go. Oh, underscore. There you go. Yeah. There you go. See, there's the hello world. There we go. So it works. I grab Thar's hammer. It works. And so, yeah. So that's the VM that we built. Everything's running. QEMU pops it up. It says hello world. That's what it's supposed to do in a perfect world. So I'm going to close that now. And of course, everything's back the way it was. All right. Now, let me scroll all the way to the bottom and get back to the testing chapter so that I know what the hell we're doing here. All right. So now that we're in the right directory with the right UI and I've busted 47 minutes trying to figure all this shite out. It's okay. It's okay. It's a learning experience. Everybody's learning. You know, if I actually went in and edited all this stuff out, I'd probably start right here and I'd be like, "Hey, everybody, we're going to learn Rust today." And it'd be like, all the 30 minutes before it didn't exist, which means, yeah, hey, MSEC, yeah, yeah, it's good stuff. Yeah, thanks. I appreciate that. Sorry, yeah. So yeah, I would cut out about the first 35 minutes of this and go, okay, yeah, none of that's good. That's all hot garbage. Just throw that away. Um, all right, so we're in the right directory here, and we're back. Let me see where did we need to be on? Okay, custom test frameworks feature. This feature no external libraries. We need a test case code bit here, and then invoking a user specified runner function with the list of tests as an argument. Thus, it gives the implementation maximal control over the testing process. The disadvantage compared to the default test framework is that many advanced features, such as should panic tests, are not available. Instead, it's up to the implementation to provide such features itself if needed. This is ideal for us since we have a very special execution environment where the default implementations of such advanced features probably wouldn't work anyway. Good point. For example, the should panic attribute relies on stack unwinding to catch the panics, which we disabled for our kernel. To implement a test framework for our kernel, we add the following to our main.rs. All right, so we're going to go back to main.rs and we're going to add, I believe we will add this at the top of the doc because you see the whiz bang statements, which would probably go right about here. Guessing. Okay, I got a new watch and it's trying to tell me what I should and shouldn't do. All right, and paste. So we've added these features, custom testing frameworks. Oh, you got little pop-ups here. Tracking issue for this features 50,297 allows the use of test case and whiz bang test runner. Okay. And so we have test runner. We have a crate called test runner that we're going to need to add. We've added a config test, so function test runner. So here's the test runner function that we've got up here. Din is yeah, so it's dynamically dispatched. Use this trait. Use the trait this way. It must be object safe. Okay. And then println running test len, and then so we've got some additional bits here. And they better explain it over here. Our runner just prints a short debug message, then calls each test function in the list. The argument type, din function, is a slice of trait object references of the fn trait. Is basically a list of references to types that can be called like a function. Since the function is useless for non-tests, we use the config test attribute to include it only for tests. When we run our cargo test now, we will see that it succeeds if it doesn't see note below. Okay, so I'm going to have to see the note below because invariably I pooched something way back in then. So I'm going to go cargo test. Oh. Oh. Ah. Ah. Got me. Got me. Okay, the language item first defined in crate core, which spin depends on. First definition of core is loaded from these various places. So there's about 150 of these things. There's currently a bug in cargo that leads to duplicate language item errors on cargo tests. In some cases, it occurs when you have set panic abort for a profile in your cargo toml. Try removing it and then test cargo should work. Okay, so we need to go to cargo toml, file. And you see it right here where it says panic abort, panic release. So we need you. Okay, so No, Lady P. No, Lady P. I I thought we were doing all right, and I expected the errors because I just it is what it is. So I will comment this out according to. I'm going to comment both of them out because I don't want to have to try to figure out which is which. Because also the person does not mention here which one to remove, and there's two. So I'm gonna start over. Oh, okay. So that's didn't save it. Didn't save it. So I will save the cargo toml file. There we go. Now I can run it again. There we go. Can't find crate for test. Okay, that's good. That's better. So do I need to add? Did it mention anything about adding a crate? Yes, can't find crate for test since it is not available on our bare metal. It is highly unstable. Requires. Okay, so it did work this time in a manner of speaking. We still see our hello world message instead of our. However, we still see our hello world instead of the message for our test runner. The reason is our start function can be used as an entry point. I need to add. Let's see, main. Oh, again, I did not save the main RS, so there we go. There you go. See, got to remember to save stuff. I'm trying to get back, That's what you get for half-assing this programming thing instead of doing it regularly. Been a little busy learning DaVinci Resolve for my other project, as if I don't have enough side pieces as well. So my side piece has a side piece now. So working on some graphic design stuff as well. Um, so yeah, there's the hello world, but there's like it says, there's no information in there. The start function, the custom test frameworks generate a main function call, but it's ignored. So to fix this, we'll need to change the name of the generated function to something different than main through the re-export test harness main attribute. It's starting to sound like Java, where you've got stuff that's beyond my screen size here. Okay, there we go. Yeah. So they're at least this long, the variable names. Still can't believe that. All right, so in main RS, which is right here, re-export test harness main test main. All right, so we will add that here. Copy main RS. I will add it right there because I'm assuming that everything kind of needs to be grouped together. We'll see. Under no mangle, so we've got the no mangle bits here. Stern C, func start, hello world, and then in between we need to put our CFG test, copy, and then we'll put that right there. So I'm trying to reduce the amount of time and errors here, so that's why I'm copy pasting. So I would suggest typing these in as normal if you want to get into the muscle memory of all of that. So there we go. How's my audio? Is it good? Okay, I'm good. All right. So we set the name of the test framework. I hope you're doing okay, Lady P. Glad you're doing okay. Glad you were able to show up here today. I saw some of your stuff on Twitter. I'm sorry that's happening to you. So my condolences, and I hope you take them to the cleaners. So hello, lol enjoyer 223. Thank you for coming. Thank you for visiting. If you have any questions, please ask. All right, so I probably can't answer them, but we'll Google them and figure them out. We set the name of the test framework entry function to test main _ main and call it from our _ start entry point. So that's what we've done here. Best stream ever. Well, thank you, 223. Appreciate that. The ones of people who come and visit our stream do think it's the best. I'm just slowly trying to build up my my following, and it's taken a bit. So I appreciate the positive thoughts there. Thank you, Lol Enjoyer. Thank you. We set the name of the test framework entry to test main and call it from our start entry point. We use conditional compilation to add a conditional compilation for those of us who aren't sure. Rust has a special attribute which allows you to compile code based on a flag passed to the compiler. So very similar to how you might config other things, but this seems to be some shorthand to allow you to not have to type the same thing in over and over again, including things like targets, arches, target OSs, bit types, or pointer widths, 32 bits versus 64, adding additional variables, like strict, or report on all errors. I don't know if Rust has a strict mode or not, but this will give you some idea, and you can disable them in your cargo.toml file. So, oh, this is the outdated version. So yeah, okay. So there's a better version for that, but this will give you an example from the. There you go. There's that. All right. I'm gonna slow it down a little bit here. All righty. Okay, so we'll use conditional compilation to add the call to test main only in test contexts because the function is not generated on a normal run. Now we execute cargo test. Well, when we now execute our cargo test, we'll see running 0 tests message from our test runner on the screen. Okay. That was interesting. Test exited abnormally. See the full output pass, no capture to the harness. Well, I didn't do anything, so let me control S. Let me save that. Let me save the cargo toml file. Let me save the VGA buffers. Let me save all my JSON files. I'm just going to save everything and then close out just the ones that we need. So I'm going to get rid of buffers. We're just going to keep the cargo toml file and the main RS file up and running. And then we will cargo test. There we go. Okay, so you see here in very small print, apologies for that. You see it says running 0 tests. That's because we don't have any tests defined, but it will take those tests now when we go and we try to run, or when we add config.test, I believe is what we'll need to add to that to make it work. So yeah. All right. So yeah. All right. Now it actually worked. Huzzah! I'll have a celebratory drink of water. Huzzah! All right. Now we execute cargo test. We'll see that, yes. We're now ready to create our first test functions. We're going to create our first test function, test number 1, numero 1, in main RS. All right, so there we go, main RS. We're going to add a test case. I'm assuming that's going to, it doesn't say where to put it. So I'm hoping that it doesn't matter where we put it. I'm going to put it at the bottom. So I'm hoping because that ties to that one per. Oh wait, let me close. Close. There we go. All right. So this bracket matches this bracket up here. Yep. If that font is too small, let me know. I think it's okay. I'm looking at it on a very small output, but on a very small screen. So, all right, I will put this test case right here. So we have a test case. The function is called trivial assertion. Trivial assertion. That's the worst game ever. I like Trivial Pursuit better. That's a dad joke. Sorry. So it'll print trivial assertion. It'll assert equals 1, right? So on panic, this macro will print the values of the expressions with their debug representations like assert. This macro has a second form where the custom panic messages can be provided. So its second form is its ultimate form. Println, okay. So what should happen is when I save this and we run this, there you go. So we have trivial assertion, okay, running 1 test. So that worked. Test case was created, func worked, We printed trivial assertion. I'm assuming we asserted equals 1, something very similar to that, I'm guessing. And I'm assuming if that equated to be true, then you print len okay. I don't know. Can we go 1 = 2? This is me messing things up. It's all right. Come along with me. Oh, yep, system hung, right? That's interesting because the assertion did not equal, right? So 1 = 2. So the assertion didn't do a hello world. It's probably hung waiting for something. So I'm going to go ahead and close that if I can, which I don't appear to be able to close that. Knowing my luck, I just caused a memory leak and then I pooched it. So let me change that back. I will save it and rerun the system. And of course, so yeah. So assert EQ is probably like assert equals 1, 1. So as long as they both match, everything is copacetic. So if I had to change this to 2, 2, it still is equal, so it still works, right? Let me close my QEMU window again, and we'll give it a shot. Yep, see? All right, so as long as those two values matched, everything was good. But once they did not, bad things happened and hung. So there you go. You do it so well, though. Thank you, Lady P. Sometimes I'm wondering if I shouldn't, just what, I'm a programmer, but my eyes are always closed. They're either got blinders on, or I'm just afraid something's not going to compile right. So anyway, let me put this back 1 = 1 for all intents and purposes. Control S. All right. Now, when we run cargo tests, we see the following output. So yeah, everything worked there. The tests slice, which is passed to our test runner function, now contains a reference to the trivial assertion function. From the trivial assertion OK output screen, we see that the test was called and that it succeeded. After executing the tests, our test runner returns to the test main function, which in turn returns to our _start entry point. So everything kind of builds back into startup. So when we run it, the VM starts, hello world is printed, and then it runs and goes through our test creation stuff. Okay, great. Oh, it's because I moved. My wild gesticulations is causing my watch to assume that I've done something. Okay, so at the end of the _start, we enter an endless loop because the entry point function is not allowed to return. This is a problem because we want cargo test to exit after running all tests. Okay, so the fact that I can run cargo test and it sits here, it's just constantly running through an endless loop. There's nothing making it error out. The idea is after it runs the test, it should close the QEMU and then go back to a container. So, but what I'm doing is the ugly way of doing it. I'm just closing QEMU and then it's done, right? So you hate Linux, and I've decided you could do a better job. We're watching yes, Lady P, the irony is not lost on me that I've turned my back on Linux again, and now I can do better. I can build a better Linux, by God, all in Rust. So come with me. I look forward to all the angel money that's about to drop into my Patreon. Yeah. Oh my God. Yes, Lady P, you got me there. I am now deaded from that. That's pretty hilarious. That is not lost on me. Now I wonder why the QEM. Oh, that's because this is the output on this screen. Yeah. So I can build a better Linux because I'm just like Richard Stallman, except I have shoes on and stuff, and I don't live in Portland. And I don't have much of a beard. I've got a bit of an evil goatee. My evil twin is in the alternate universe. He doesn't have any facial hair. So. All right. So as they said, we want cargo test to exit after running all the tests. So when we run cargo test, QEMU will pop up. It'll give us our error messages, and then it'll die, right? Right now, what I'm doing is I'm clicking X to kill it, which is not the nice way of doing it. It is a way of doing it. Depending on the test, I don't know what would happen. Maybe there's some abandoned processes involved there, some orphaned bits. I don't know what's going on under the hood there. But I would assume the more complicated the tests, the more tests that happen, the more time that is being spent. So you need to, keep an eye out on that. So it says exiting QEMU. Right now we have an endless loop at the end of our start function. We need to close QEMU manually, clicking the X at each started cargo test. Just like RMS, except you're not a raving a-hole. Well, 2 out of 3 ain't bad, right? 2 out of 3. Yeah. Was that? Yeah, Meatloaf said 2 out of 3 ain't bad. Figure out which ones those are. We'll get there. So we need an underscore start function. We need to close QEMU manually on each execution of cargo test. Now, what I'm wondering is, at some point, if it closes it manually after I run the one test and it closes the box, am I going to actually see if anything happened? Or is it going to have to be where, I'm going to need to have some logs logged somewhere? That would be ideal. Where it would say, okay, I'm, going to run this test. Here's the output log. We're going to put it here, that kind of thing. Right now, we don't have that option, but what's going to happen is we're going to add this bit, in our cargo toml. Copy. And then so go to cargo toml, and we will add package. We will need to add test args. I think, package. Yeah, I think we're going to need this whole thing. Yeah. Copy. So we're going to need to add that. There we go. And then Control S. And so the boot image runner appends the test-args to the default QEMU command for all test executables. For a normal cargo run, the arguments are ignored. Together with the device name ISA debug exit, we pass 2 parameters, IO base and IO size, that specify the IO port through which the device can be reached from our kernel. All right. So we're creating an ISA, which is old school architecture. Well, old school for me, not old school for everyone else, because ISA was like, I had a couple ISA slots on one of my oldest computers I used to have when I was a kid. Sorry, Lady P. Mostly used for things like graphic sound cards and I believe printer cards. Yeah, I think so. I seem to remember an ISA sound card, definitely. And I believe, yeah, there was another peripheral I had that was plugged into ISA, because it went ISA and then PCI was the new hotness, and now it's like PCI 4 is like I think the latest version right now, which you use for like graphics cards like the one I have on my computer right now. But it was a much longer port. Yeah, so you can go look that up historically if you'd like. So together with the device, there are 2 different approaches for communicating between the CPU and peripheral hardware on x86. Memory mapped I/O, MMIO, and port mapped I/O. We already used memory mapped I/O for accessing the VGA buffer at memory B8000. So we're injecting ourselves using an unsafe method into B8000 in the VGA buffer, and we saw that earlier when I mentioned it earlier in the stream. This address is not mapped to RAM, but to some memory on the VGA device. So yes, we're not actually injecting ourselves into memory. We're injecting ourselves into the graphics card on my computer. In contrast, port mapped I/O uses a separate I/O bus for communication. Now, if I'm wrong, somebody let me know. If I'm injecting myself, I should be directing myself directly into the VGA buffer that exists on my NVIDIA 3060 card right now. Creative Labs, yes. The Sound Blaster, yes. Sound Blaster ISA, yes. And then everybody loved the Sound Blaster 32-bit. Yeah, eISA was 32-bit. Oh, I see. Okay. I don't remember eISA so much. I do remember 16-bit ISA. Yeah, I had a Sound Blaster, I think ISA sound card at one point. Yeah, so yeah, a lot of good stuff there. So a lot of ISO device. You know, some of the older, I think you could run, I think I had a serial, I want to say we had a serial multiplexer at one time on an ISA card at work in one of our early machines left over from when we needed to hook up printers or um, serial terminals. So, man, jogging the brain plaque off today. So it's pretty good. So yes, the ISA debug exit device uses a port map to I/O. The I/O base parameter specifies on which port address the device should live. F4 is generally unused port on x86's I/O bus, and the I/O size specifies the port size. So 04 means 4 bytes. So it's not a lot of space, right? We just need a little bit, 4 bytes, and located at F4 in this case. Using the exit device. So the exit device, I believe it's a virtual device, right? Just like QEMU is virtual, but we can create virtual devices that sit in memory and will act. And that's what we're doing here. I think we're creating a virtual memory device that when it gets called, it knows exactly what to do. In this case, it's going to shut down QEMU for us. eISA spread down the entire length of the motherboard. Yes, it was a very long. Okay, so maybe it was eISA. I was ignorant at that time. It was probably like early, yeah. ISA V1 was a short little hand-sized port. ISA V2 had almost 2 ISA V1 slots back to back. I'm resting my elbow on a 386 right now that has an 8-bit ISA slot, 5 16-bit ISAs, and a 32-bit eISA slot. All right, let's go look at eISA 32-bit motherboard. All right, so there you go. There we go. All right. So yeah, there you go. So these here, well, double damn it. All right, so there we go. So these are the 16-bit ISA, right? These are the 32 bits. These are the big long ones here that you see on the screen. And so yeah, there's a bunch of them on there. Opti, yeah, I remember those. Yes. These white ones here, of course, were the RAM, and probably different kinds of RAM. It looks like. Oh yeah, so there you go. You got jumpers, your J9 jumper, yes. So yeah, there's a number of different things. So yeah, here's the CPUs. Oh, I had dual CPUs, 486 CPU DX2. Those were nice. Those were fancy. Yeah, here's the eISA slots. So those are the 7 eISA slots. Those are the big ones we were talking about, and VLB connectors. And then 128 megs of RAM. Whoa. Oh, okay. So yeah, these were SIMs. So not like DIMMs like what we have now. These are SIMs. So one side single memory module. So what you see here, these were memory modules. These are memory modules. These were other memory modules. Yes, this is a 46. I think DX is what it said for the build. This is the Intel or what have you back in the day had pins that would sit inside, and you would be able to big old fat processor, and you could put the thermal glue on it and everything. Yeah, here's your cache RAM. Your cache RAM is the cheap stuff, or the stuff not cheap, but you could expand your cache RAM up. Oh yeah, here's your BIOS, your AMT, the American Megatrends, not Phoenix, AMT. And yeah, here's an ISA card of some type. You can scroll down here and it'll show you. Yeah, here's an Adaptec. I think that's a SCSI controller. I want to say it's a SCSI controller. Yeah, I think I had an Adaptec SCSI card as well. So that second slot's not a CPU; it's the math coprocessor. Oh, which one? Which one was I saying was the math coprocessor? Because they were saying, so according to this, socket 2 supporting a 486 CPU up to DX2 plus overdrive. Okay. Plus clock doubled models. Okay. Yeah. Yeah. This is way better than the one that I had when I was a kid. So mine was an 8088 processor kind of thing. So, but yeah, yeah, SCSI cards. SCSI cards were another thing you put in ISA because you could hook up SCSI drives to it too. So that was the other thing. Yeah. Anyway, I digress. My apologies. I love looking at technology like this and seeing how far we've come and how much less buggy I think it was back then. Things tend to be a little more buggy now, especially with the machine that I've got. I think I've got it stabilized now, but every once in a while that graphics card will come unhinged and just run my day. So I just added an 80387 math coprocessor to my 386. You know what, Lady P? I wish you'd been up in Seattle with me a couple years ago. Well, yeah, they had like a computer museum with, it was pretty much one of your playgrounds. You would have loved to have been in there like that. I think they shut it down because it wasn't making any money. And when I was working in Leviathan at home, I think it was just around the beginning of the pandemic, they decided to shut it down because nobody was visiting it because of the pandemic, and they were about to lose their building lease or something like that. So, conditional compilation. All right, so we're going to use the exit device. The exit device is very simple, he says. When a value is written to the I/O port specified by I/O base, which, as we've established before, was 4 or F4 and F4 and O4, so 4 bytes at this address, QEMU will exit with a status of, value is, greater than 1, or less than 1, or 1. I think that's how I'm reading that. When we write 0 to the port, the QEMU will exit with the status of 0 is less than, or 1 equals 1. Wow, that sounds weird. Okay, so we've got 3 different variables or 3 different versions. So depending on the exit status, so exit status 99 or 1 or 0. Um, so that's like either true or false, or something's really gone off the rails. That's the way I'm reading it. So instead of manually invoking in and out assembly instructions, we use the abstractions provided by the x86-64 crate. We add a dependency on that crate, and we add it to the dependency section in our cargo.toml. So we need to go back into our cargo toml, which I need to control S and save. So what you see here is you see the ISO debug exit, iOS base is F4, and the IO size is 4 bytes. We're going to add x86-64 in this version of library, which will go under dependencies. So we'll put that right there. And so you see we've got it in our code right there underneath spin. And now we can use the port type provided by the crate to create an exit underscore QEMU function. So this is in main RS. So we'll save this, go back to main RS, and we're going to add in main RS under, interesting. So we're going to add these items, copy. We're going to add derive, debug clone copy partial EQ and EQ, and repr underscore 32. Then so public enum QEMU exit code. Okay, so I think we can just add this at the bottom like we did the original test case. We will find out together. And then you shall all laugh in derision at my joy or pain. Yeah, I'm going to put that at the bottom. All right, so we've added those in. These are all available. Now, I'm not adding this. This is some bullshit that VS Code is putting in addition to this port bit here. I'm not a fan of that because I'm not concerned, but if it makes them an error message, which I don't think it will, I think these are like debugging issues, but or it's giving us additional instructions or bits that we don't have. All right. This function creates a new port at F4, which is the I/O base of the ISA debug exit device. Then it writes the past exit code to the port. We use U32 because we specified the I/O size of ISA debug exit as 4 bytes. Both operations are unsafe because writing an I/O port can generally result in arbitrary behavior. So we're writing in code that's unsafe, and that's what it wants us to be aware of. I was in one of the first batch of volunteers at the San Jose Computer History Museum in Mountain View. As you might imagine, it became an extraordinary place. Oh yeah, wow, that's pretty awesome. Yeah, the Seattle Computer Museum, I think, obviously did not fare as well. Yeah, the Living Computer Museum. I don't know if it's open anymore. Yeah, temporarily closed. Yeah, so they're closed for now. I think yeah, COVID-19 had a devastating effect on cultural organizations that rely on public gatherings. In the following weeks, yeah, so I think they added this about a year ago, but they haven't reopened since. But it was a really cool place. We had our I think one of our Christmas parties was there, so there's a lot of interesting technology and things there. So, um, but yeah, they have ticket membership, donation refunds. I think they were just getting out of it. So yeah, they had a they talked about the closure of that. So computerhistory.org. Oh, there you go. So yeah, it's got everything. It's got a lot of things. I'd imagine it has a lot of different technologies that are available. They're open. That's cool. They had a go at it. So um, it's cool they were able to stay afloat during the pandemic because that's like I said what killed the Seattle version of this. So it's good that they've got that. All right, so we'll create a QEMU exit code enum. The idea is to exit with the exit code if all tests succeeded, and with the failure exit code otherwise. The enum is marked as repr underscore 32 to represent underscore unsigned 32-bit. So U32 is unsigned 32-bit. Silicon Valley, they've been around for yeah. I'd imagine your Wozniaks and all the folks that built their shit in the garage and are now billionaires. And they have an affinity to making sure that the history stays open. And I'm not gonna say one was better managed than the other. Obviously, there were some issues that happened in Seattle due to the pandemic that was different than SFO. Things happen, that kind of thing. So actual codes don't matter much as long as they don't clash with the default exit codes of QEMU. For example, exit code 0 for success is not a good idea because that becomes 1 greater or less than 1, 1, or 1 equals 1 after the transformation, which is the default exit code when QEMU fails to run. So we cannot differentiate a QEMU error from a successful run. We can now update our test runner to exit QEMU after all the tests we've run. So in main RS, we need, okay, so we're going to change our, let's see, where is it? Function. Oh, wait. There we go. It's a test case. Function test runner. Where's the test runner function at? Oh, here it is. Okay. So function test runner tests din. Okay. Println running test for tests. Int. Okay. Test. Then we need to add this line here after this line. So there we go. We need to just add that QEMU exit code. Okay, so yeah, VS Code's adding these little bits to let us know that this is where an exit code lives. Okay. I'm assuming in more complicated code, or if you spent all 10,000 lines, you're going to want that information in there. So, Okay, so that's good. Control S. Yeah, good. Now when we run cargo test, we see QEMU immediately closes after executing the test. The problem is that cargo test interprets the test has failed even though we pass our success exit code. All right, so I'm going to run that. Okay, watch for it. Watch. Oh, what? Link for anyone who wants to see that. Ah, yeah, there you go. Computer history. Yeah, there you go. Funny, you mentioned that one in particular not long ago. The CHM finally got the go ahead to release the Apple Lisa's OS source code. Yeah, there you go. Oh, was yeah. Actually, I think I saw because there was a story about Wozniak having a he was in Mexico and had a stroke, or that's what they're reporting. They're saying that, yeah, he's doing good after a minor stroke, according to the New York Times. He was in Mexico City. He's now back home in his mega mansion in California after a brief stay in a Mexico hospital. So that was on the 9th. So that was yesterday. Suffered a dizzy spell, took a precautionary trip to the hospital. He suffered a minor stroke. A day later, he said he was doing good. So they did an MRI and determined he had a capillary leak as well as symptoms of vertigo. So, yow. Hospital required him to stay on a gurney for 24 hours, wouldn't let him roll onto his side. The health scare, he added, means that he will have to cancel a number of trips for speaking engagements in Dubai, Medellin, and Baku, Azerbaijan. Yeah, that sucks. You definitely don't want to fly with a potential capillary leak in your brain. Oh, yeah, yeah. He is 73, so he flew home to Los Gatos. I'm assuming that somebody chartered a jet for him. He's not flying, commercial. Well, maybe he is. Who knows? Um, but yeah, it's unfortunate. When he goes, that'll be a sad day for everybody in the computer world. So, hmm. Okay, so not applicable here. Okay, so let me see. All right, so in tried and true method here, I'm going to go and look at blog post 4, branch 4, which will give us our code source, main RS, and it's interesting. So they don't have the derived functions in there. They have no standard, no main feature, test runner, okay, and re-export. So they don't have this. They don't have the repr in here at the bottom anymore either. So at some point in this chapter 4, he's going to remove those. So I'm going to, can I comment those out? Probably not. I'm going to remove them and see what it will do to the code. No, not going to do that. It was giving me a ton of error messages issues. So that's, cannot find copy in this scope. Rust C, not found in this scope. Okay. Terminal. Okay. Says it's not applicable. Derived may only be applied to structs, enums, and unions. And this is not a struct, enum, or union. Okay, I know that. Why did you make me put the derive in? I don't understand that. Now use the port type provided to create a QEMU function. Oh, you know what? wondering if I didn't save that. Now I'll save it again. Probably the same thing. Okay, so okay, I did save the cargo toml file, so that is fine. Did I copy something in wrong? Hub. Oh, did I not add the success? Didn't add the QEMU exit codes and stuff, did I? Well, that's because oh, I did right there. I'm wondering if I have to add them like immediately right after the code. Okay, so this might be a case where I actually do need to have it in the right place, which would be immediately calling it right after the code. See, he makes these inferences like I know where the hell I'm supposed to put this shit. So let me see if that makes any difference. Da, 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 there it is. There it is. Okay, so yeah, you have to put the enumerations right after you call them, apparently. So there you go. So many nuances that you need to understand. Sometimes the error messages are just because you put the code in the wrong place, right? So yeah, the enum bit that we called, because it said the derive is, there's no enum, so you have to put that in before. So that's why that ended up where it was. So everything needed to go before that. My bad. So there you go. If you're watching this and you were screaming that 20 minutes ago, join the stream and then you can scream at me in chat like Lady P and Age and the other person who was in here earlier. So which is lol enjoyer. So yeah, there you go. Lol. So there we go. All right. Okay, so that worked. I need to scroll back down. I did say we were going to get an error anyway. Yeah, test failed. Rerun. There's our error message right there. Problem is that cargo test considers all error codes other than 0 as a failure. So yeah, anything other than 0 is not good. So we need a success error code. To work around this, boot image provides a test success exit code configuration key. Of course it does. You've got several lurkers. Hi, lurkers. Yes, lurkers, come and join us. Come and join. Come and hang out and unlurk. It's okay. You're safe here. It's a safe tree. It's a safe place. I ridicule myself just as much as you would ridicule me. And Lady P is always awesome. Lady P keeps me grounded. All right, we need in cargo toml or cargo toml file. We need a package metadata boot image. So I want to say we've already got that. All right, package metadata boot image. We've got our test args, which I'm not sure what that means. I'm assuming it means keep the same thing, but then we're going to include that. It's safe unless you're yes, it's safe unless you're Rust code. So if you're Rust code, masquerading as a person, if you identify as Rust code, then yeah, there might be some words said. But yeah. So all right, I'm assuming that this means keep the same shit that was in there before. Don't make any changes. And then your exit code is 33. So what we're looking for is something called 33 for the exit code as being, good to go, and that'll be the error message. With this config, boot image maps our success exit code to code 0. So 33 is now the new 0. So that cargo test correctly recognizes the success case and does not count the test as failed. Okay, that's cool. All right, so we'll save that. I'll resave my main RS before I try to build this again. Wait a minute. Let me double check and make sure that we're supposed to. We still see the QEMU window open for a very short time, but it does not suffice to read the results. It would be nice if we could print the test results to the console instead so we can see them after QEMU exits. Or better, the console and a debug log. I'm assuming at some point we will have logs where it will write to some place to keep that. So we're just going to run this right now. Okay, so it was super quick, right? So watch again. Oh, it's so quick it doesn't even show up on the screen. I mean, it's like blip blip, it's done because there's only one test actually. So literally, it opened and then closed, and it was so quick that even OBS can't pick it up as the window. So we'll get it. We'll get there. We'll get there. How much more time? Out of my, okay. How much more do we got? Okay, so printing the console. I don't want to go any further if it's going to be a big. Yeah, there's a lot here. There's still a lot here. Okay. Yeah, I think I want to get my week started. For everybody, we stopped here. So this is where we stopped, and what I'll do is I will put it in as a. Should be able to do that. That's how remarks work, right? Right? Oh no, slash slash. My bad. Okay, so it's slash slash. All right, there we go. And then I'll save that, and then that's where we ended up. Last ended at here on 10 November 2023. There we go. All right, so that's where I know we will be, and then that way I will also remember to not pooch anything when we do that. All right. So Saturday I'm at Mamma Mia. Sunday we will be heading up to SoFi Stadium in LA to watch the Chargers probably get their ass whooped by the Lions. That's an American U.S. hand egg or football for those of you who enjoy that. Doink. I'm also working on. Ooh, I'm a little overexposed. Let me turn me down. There we go. Okay. I'm also working on my side piece. There's another little thing I'm doing. It involves dice and a multi-camera setup, if you will. So I'm using it to teach myself DaVinci Resolve, learning how to do jump cuts and things. Eventually, I'll move that over to this, but it does take a non-zero amount of hours additional to the recording to make things look pretty. I'm also investigating DaVinci Resolve. The paid version has transcription, which actually works really well. The other place I'm using for transcription, which I can do for these videos, and it doesn't take a lot of time, is Riverside.fm has a nice, where is it? Transcriptions. Here it is. So Riverside.ai.fm does actually surprisingly good, better than Otter.ai when I looked at it about a year ago. You just drop a file into the system. Whisper murder. So far, I haven't tried it with multi people. I've only done it with myself, but and Whisper is free and open source. Whisper. Oh, okay. Yeah, Whisper is open source. Okay, so it's another option. This is free as well. I'm sure what I'm doing is I'm helping to train its AI, so I'm okay with that. You know, it's free, so I'm obviously the product. But it works well enough that I can go back in and it's like somebody figured out the UI. It's like, oh, I can go in and I'm listening to the audio at the same time I'm transcribing, or the UI is such is in DaVinci Resolve that I can go in and as I'm listening to the video and the audio, I can click on the piece of imported subtitle and go, okay, that's where I need to put it. So this uses AI technology as well. So you just grab an MP3 or whatever and upload it and go. Whisper. There you go. Nope. Oh, and there's Whisper transcription for Mac. OpenAI Whisper. There we go. OpenAI Whisper transcribe your stuff. Let's see. Yeah, yeah, and yeah, you can also save in Riverside as an SRT file, so it's text only. Um, DaVinci will also allow you to do things like make changes to the text, change the fonts, sizes, locations, that kind of thing. So I'm playing around with that to understand how that works. So, but yeah, so yeah, VTT or SRT files are what you want to use for most any captioning or transcription. Um, yeah, Riverside's not very long. It depends on how long you actually have the video. So an hour and a half for me. I think it took like 5 minutes, but DaVinci Resolve was quite a bit faster, and also synced the time codes, which was important for me to make sure that I got everything right and I wasn't like showing something on the screen that wasn't me talking. So I use Whisper in my LLM that has replaced the Amazon Echo. I have a communicator badge that runs a LoRa radio, real time audio over LoRa to my AI. Oh, that's pretty cool. Laura. Um, yeah, yeah, yeah. Okay. Very interesting. At some point, Lady P, I need to have you on the show just to have you talk about everything that you're working on. Because LLM is hot. Uh, you're obviously working on some cutting edge shite. If we can get you on, that is not going to ruin your IP or ruin your next major startup, that would be great. I have no problem with that. Longer show, the better. We'll do a 12-hour show or something like that. Maybe we'll do that for our 3-year anniversary on March 6th of 2024. So yeah, cool. That there's a lot of free stuff out there now that's using obviously OpenAI or what have you. Riverside is great. I mean, there's Otter.ai. Some of them do things completely free. Some of them will do so many hours a month. Some of them will actually pay you. Actually, Otter.ai at one point was like, "Hey, we've got people who will transcribe it for you." I was like, "Wow!" And why? So yeah, that's kind of interesting. So yeah, Whisper. Oh yeah, so there you go. There's the GitHub for OpenAI and Whisper, speech recog. So um, I'm assuming it gets better over time. So here's how oh, sorry, I'm not showing my browser. There you go. Here's how the magic happens. And you can, sequence to sequence, all the fancy stuff that's going on there. It's definitely better than the captions that come from OBS and Windows, which was hot garbage, as Lady P was telling me that was being shat out onto the screen at some point during the stream that I was doing where I was trying the experimental captions bit. Complete shite, and yeah, should not have been done. So, if Kaiser's to be believed, I'll be having major surgery. Oh, I hope. Oh, Whisper V3 was just announced at AI Dev Day. I haven't looked at V3 yet. Oh, okay. No, Lady P, Kaiser doesn't want you murdered or whatever. That's they they pooched it, right? I just had a discussion with my UCSD doctor over chat on my phone, like a Zoom call. I'm unhappy with what they gave me with regard to my leg and my. They said they said the right side on my right leg had venous insufficiency, which is the veins got damaged or the valves in my leg got damaged, so the blood is kind of dropping back down. Problem is, my right leg is fine. It's the left leg that's the problem. So they're like, well, we need to go back to the ultrasound techs and find out if they switched left and right. And I was like, that's probably a good idea. Um, but I went out for a walk today, and my hammies are a bit tight, and my knee was aching and painful. And I think that's probably left over from an injury that I had when I slipped on some ice back in the day, which is why I was trying to figure out if the knee injury from 4 or 5 years ago is actually the problem that's causing the venous insufficiency, or if it's just I started working out again and I had enough clots or uh, cramps in my legs that was causing issues. So I don't know. Yeah, so I get to go see a vascular surgeon in Hillcrest in January because that's the earliest they can get us. So I wrote "not this side" with a Sharpie when I had cancer surgery a while back. Oh my goodness. Um, that's a good idea. Yeah, I think they, people joke about that, but they literally do put, this knee, not this knee, or whatever when they're going through that stuff. All right. Well, I'm gonna go. Want to thank everybody who are veterans. Being a veteran myself, we deal with a lot of shit. We're part of an interesting or fraternity or fraternal organization, organization period. Being veterans, we don't. I don't think we get our due in many cases, and I'm really, really lucky that my 7 years in the Navy didn't leave me a completely wasted Hulk who was unable to function in normal society. So I'm very thankful for the military for giving me the skills that they gave me. And I'm very privileged in understanding that my life and career could have gone way differently uh, without the Navy. So if you're a veteran, thank you for serving. If thank your family for serving alongside with you. And yeah, I'm gonna go and happy birthday to Uncle Sam's misguided children. I will say that the military is not for everybody. Um, I obviously would not have made it out of Missouri without the Navy, and I actually thank my mother for this. Even though she feels like I would, she kicked me out of the house when I was 18. I was like, I had nowhere to go and completely aimless. So um, would not have gone to college probably, and would have ended up doing God knows what. So, very, very thankful to Uncle Sam's misguided children. I am, of which I am one. Uh, oh yeah, today, yeah, they're actually. I think I saw a post on Twitter. There, they actually were created before the United States was a country. So that was kind of cool. Hoorah! So yeah, there you go. Thank you to all of my Marine Corps friends, Army, Navy, Air Force, Coast Guard, Marines, Space Force, and even the NOAA Corps. NOAA Corps has an oceanograph. They're like Starfleet with their humanitarian missions, or they explore. So anyway, I'm gonna go. Thank everyone for having spending time with me. Uh, Lady P, Age, Beta Wolf a little bit there, Lol and Joy, MSec. Thank you all. And we'll see you hopefully next Monday or Tuesday. So I'm going to take the day off on Monday because I earned it. I'm a fucking veteran. So, but yeah, I'll see you on Tuesday. All right. Y'all have a good day. Bye, y'all.